In this video lecture, we are going to be talking about atomic structure, but we are focusing now on electrons. You've spent some time talking about protons and neutrons in the ions and isotopes video, and we talked a little bit about how the electrons figure in the ions portion of that video, but I want to dig a little bit deeper and I want to teach you guys how to draw Bohr models. So you learned from the history of history of atomic structure video that there has been a lot of changes to our understanding of the atom over time. The atom itself has not changed, it's just our understanding of it that has changed. And while the Bohr model is not the most current model, that would be Schrödinger and Heisenberg's electron cloud model, the Bohr model is the best way for us to visually describe the location of particles like protons, neutrons, and electrons because it is so straightforward. You can see in the diagram over here, we've got our nucleus, we've got an electron in energy levels, we've got multiple energy levels. This is a lot easier to draw than the electron cloud model, which has a nucleus and then electrons in a probability curve around. I'm not going to do this forever. No, this is already too annoying. All right, so we're going to use Bohr models as an easier way to describe the location of electrons rather than the electron cloud model. The energy levels are different sizes because atoms are different sizes. The smaller the atom is, the fewer number of electrons it can hold, the fewer number of energy levels that it has. So hydrogen being a very, very, very small atom, the smallest, this is hydrogen over here, right? It only has one electron. That one electron goes in the first energy level. You'll notice that the first energy level is very small. Small energy level can only contain a certain number of electrons. So here is the breakdown. The first energy level can hold 2 electrons. Now, electrons are negatively charged, which means they do not want to be by each other. So these electrons spread themselves out as far away from each other as possible. So you can see in the first energy level, they're on opposite sides from each other. Now, if we had a larger atom, something more like lithium or carbon, we would have to start filling the second energy level. The second energy level, so this is the first, the second energy level can hold 8 electrons. So again, they would want to spread out from each other. We're talking all the way apart. Looks like I got 8 now. Okay? So 8 electrons can fit in that second energy level. Then we're getting even bigger. Third energy level can hold 18. I'm not going to draw all 18. That's too much work. All right? The fourth energy level can hold 32. So from there, we have more and more energy levels. There's 7 energy levels total, but you only need to know up to the fourth. Every energy level after the fourth has 32. So the fifth energy level can hold 32 electrons. The sixth energy level can hold 32 electrons. The seventh can hold 32. That's all you need to know. So 2, 8, 18, 32, and then it's just 32 from there on out. But if we wanted to draw the most accurate Bohr model, we would do it this way. But drawing sometimes 64 electrons can get pretty tedious, and I don't want you to have to spend your days counting how many electrons you drew. So we are going to learn a condensed way of drawing the Bohr model. So it's not going to be exactly the Bohr model, but it will be that synthesized version of it for our purposes in this class. So, for example, we are going to draw the Bohr model for beryllium-9. Step number 1, we need to determine how many protons, neutrons, and electrons we have in the atom. So you'll need your periodic table handy, and you'll need to find beryllium. Beryllium is number 4 on the periodic table, so there are 4 protons. Then we see that the mass number is 9. So to find the mass number, we know we have protons plus neutrons. So if I want to determine the number of neutrons, I take 9 minus 4 and I get 5. Then this doesn't say anything about a charge on my atom, so we assume that it is neutral. Because we have that neutral atom, we are going to have the same number of protons and electrons. So that should be 4 electrons. Now that we know how many protons, neutrons, and electrons we have, we can get started actually drawing this model. So to draw the nucleus of the atom, we are just going to draw a circle. And instead of drawing all those little protons and neutrons like we saw in the Pogles, we are just going to write the number of protons. So the number of protons is 4, the number of neutrons is 5. That will suffice for our nucleus. That's step 2. Step 3, we're going to place the electrons in rings around the atom. Except I don't want you to actually go through the process of drawing the rings and drawing all the pesky little electrons. So we are just going to draw the electrons or add the electrons sort of as a subscript over here on the top right. So remember that there's only a certain number of electrons in each energy level. It goes 2, 8, 18, 32. So the first energy level can hold 2 electrons. So we write 2 electrons. But we have 4 electrons total. So 4 minus 2, we get 2 more electrons, and we need to put 2 more electrons in the second energy level. So this would be our Bohr model for beryllium-9. Let's do another example. Helium-4. So helium, remember, first thing that we need to do is determine the number of protons, neutrons, and electrons. Helium has 2 protons, has 2 neutrons, 4 minus 2 is 2, and because it's neutral, we also have 2 electrons. So if I want to draw that Bohr model, I'm going to draw my nucleus. Inside my nucleus, I have 2 protons, and I have 2 neutrons. I have 2 electrons in the first energy level because that's all that can fit in the first energy level, but also because I only have 2 electrons. So this is the Bohr model for helium. Next up is neon 21. So again, first thing we need to do is determine the number of protons. Neon is number 10 on the periodic table, so we have 10 protons. To determine the number of neutrons, we take 21 minus 10, so we have 11 neutrons. And then for the electrons, we have the same number as our protons, since this is a neutral atom. So we have 10 electrons. Drawing the Bohr model, we have the nucleus. Inside the nucleus, we have 10 protons, and we have 11 neutrons. All right, we've got 10 electrons total. Now we need to place those in rings around the nucleus. So the first energy level can hold 2 electrons, so minus 2. Now we have 8 left. Luckily, the second energy level can hold 8 electrons. So that's our Bohr model. See how this works? Go ahead and try to complete Silicon 29 on your own. Remember, first step, determine protons, neutrons, and electrons, then try to draw the Bohr model. So pause the video, try this out. All right, so for Silicon 29 over here, remember with our isotope notation, this number on the top left is the mass number. So we can easily determine the number of protons, neutrons, and electrons. Protons is on the periodic table, 14. Neutrons you find by taking 29 minus 14. And then it's neutral, so the electrons and the protons are the same. In the nucleus, we write 14 and 15, and then to figure out our energy levels, we always fill lowest to highest, and we just want to fill it up completely. So the lowest energy level has 2 electrons, second energy level can hold 8 electrons, but I still had 4 left, so those last 4 go in the third energy level. That's pretty much all there is to it for Bohr models. Please complete the atom summary packet, or the atom summary page, and there are some problems with the Bohr models on the back. Remember to email me with any questions.